This is my fourth video, but actually only my second video in which I'm actually uploading data that I've collected. So I did one video that was called Flat Earth: A Mountain of Evidence, in which I went out and collected some data and put together a video, which I need to make a follow-up video to that because there are mistakes with the math. And that is just my honest evaluation of it. I don't want to go into it right now, but my intention in this entire process is to get to the truth of what the shape of the Earth is, and to do it through my own observation and analysis. So I don't want to have someone convince me that the Earth is flat, or someone convince me that the Earth is a globe, or show me evidence that the Earth is a globe that someone else collected, like NASA or whoever it may be, or same goes for Flat Earth, that there's some evidence. And in fact, I've actually obsessively researched Flat Earth videos and looked at pretty much every Flat Earth video in existence that has to do with empirical evidence and analysis. And I've never found a smoking gun piece of evidence. That one thing that was just irrefutable, absolutely no way out of it, guaranteed the Earth is flat. Everything there's just always a little bit of doubt in everything. And so what I'm trying to do is prove it to myself through experimentation. Is the Earth flat? Is it a globe? I'm 100% neutral on the subject. Whatever it turns out to be, that's perfectly fine with me. I just want to know the truth. That's it. That is my entire intention here. So I've gone out and done a lot of experiments. You could kind of say I've been obsessed with it. If I could put up videos for every experiment I've done, I would have 20 videos up right now. But a lot of them weren't, it ended up running really late in the day and the lighting got bad and I wasn't able to get video, or maybe it was cloudy and I could barely see the mountains that I was looking at in the distance, or the whatever I was looking at. But on the camera you couldn't see them. And that kind of process has just repeated itself a lot of times. Now, recently I came up with this concept of the water level. And what this did was it actually opened up, it made testing a lot easier for me. And I don't know if this is accurate or irrefutable proof. I do know that it looks like it's a valid way of measuring the shape of the surface of the Earth to me. And what it's showing me repeatedly, along with, quite frankly, every other test that I've done, and flat earthers are going to hate me for this, and I don't know what to say, because this is what I've been finding. And I found this on the water, on lakes, on oceans, in my mountain tests, that I see what looks to me like evidence for curvature. I just do. Now, I'm not stuck on that. I'm willing to change my mind. I'm just going to present my evidence, but I have been repeatedly seeing it. So probably a lot of flat earthers are going to turn off my video right now, and that's fine. If you believe that the Earth is flat and you don't want to hear this, and this evidence is going to kind of point towards the Earth being a globe, but again, maybe it's wrong. And so I'm sure globe earthers will really appreciate this. As I said, I don't care what the shape of the Earth is. I just want to know the truth. So I'll let this run for a second here. As you can see, I've got a gallon container near me, a gallon container 60 feet away, and they're connected by a garden hose. And what I am doing is shooting straight across the horizontal line created by this water level. And I'm also shooting alongside of it in a particular direction. I did pause this a couple times. I did some editing on it already. So I'll show you what this looks like. So this is where we were parked, and there's a wide shot of the level. So I had my tripod set up right here for the camera, right behind the car, and then I had the nearer part of the level is right here, this tripod with the gallon container hanging from it, and then the other one is about 60 feet away. And I'm shooting from 6,830 feet across this horizontal line at a distant mountain that is 6,750 feet. So it's 80 feet lower, but it's 72 miles away. So at that distance, it would be virtually horizontal. If the Earth is flat, I'm assuming that that horizontal line is going to look like it's pretty much connecting with that distant mountain. So here's, this is our location. I entered in the coordinates from my phone that I got literally as I was filming, which you'll see in a little bit. And here you can see we are at 6830. There's our coordinates. And we are capturing video, shooting across the horizontal line at Granite Peak, which, as I said, is 6,750, so it's 80 feet lower, but it's 72 miles away. So it's quite a distance away. Here's the Earth curvature calculator for that. I've got 0 eye height, which I will explain in a second. People are going to argue with this, but I know it's accurate. Target distance is 72 miles. So our target hidden height is 3,450 feet, which means that the distant mountain should be, instead of 6,750 feet, it should be, what is that, 4,000 feet tall or less, 3,700 feet or something. It should be tiny. So it should be really shrunken down around the backside of the curve. Now, the reason that I have 0 feet for the eye height is because I am shooting a, let's see here. The way that I'm doing this, I'm shooting completely horizontal line. So it's as though I've taken the ocean and pulled it up to my level, so that I am shooting exactly, if let's say we're on a globe and I were to bring that globe all the way up to my eye, so I'm just expanding the globe by 1/10 of 1%, so a tiny amount. And if the ocean were right at the base of my camera, I would be shooting at the exact same angle, because I am perpendicular to the line to the what would be to the core of the Earth on a spherical Earth. So, and I'm not making an assumption I'm on a spherical Earth or a flat Earth. I'm just saying that because I'm shooting horizontally, that the target hidden height is going to be exactly what it says on the Earth curvature calculator, because it's as though I'm literally laying my camera right down an inch from the surface of water or the ocean, whatever it might be, and just shooting straight out, which, because the surface of the water right at that point would be perpendicular to a line straight to the center of the Earth, just like my line here would be, because I have the horizontal line. So let's see. So here's where we are. And here's another shot of it. It's like a parking lot here. This is the Pacific Crest Trail that comes through. A lot of people hike this. This is actually a gap that comes up out of Big Bear, and then it drops down into the Lucerne Valley, which is like a desert on the backside of the coastal range in California. And I'm set up right approximately where that pin is. You can see there's a little row of rocks here, and then some shrubs. I basically had my tripod. Near one was about there, the distant one was somewhere right around here. And you can see, if you look here, there's one of the rocks. So there's that row of rocks right here. Okay. So let's see here. Let's look at this one more time. So the basic concept is I'm shooting straight across to this mountain. On a flat Earth, that horizontal line should line up to Granite Peak or be very close. On the globe, Granite Peak is going to be way, way, way below that horizontal line. I'm assuming that. Now, people may give me reasons why it's not. And I've heard people talk about compression and ramp up, all these different things with perspective, which I'm not going to argue with. That may be the case. I'm just presenting my evidence. But I will say that I have been to this. I hike all the time. I love hiking, and my wife and I hike all the time. I've been to this location and done this observation multiple times. It always produces the same result. I've been to other locations that are near where I live. I actually live in these mountains. And I've got another observation that I'm about to load up a video on where the mountain is 42 miles away, and it's supposed to be 500 feet above the horizontal line, or 600 feet. It's actually below the horizontal line. And I've got other tests where the mountains are only 30 miles away, which in my mind, if I'm shooting over a desert and I'm up at a high elevation, 30 miles is, I don't know, I have a hard time understanding how the distortion is going to move mountains up and down that much in thin air that's 65, 70 degrees on a very clear day and on multiple observations. But anyway, I'm getting off track here. My point is that I've witnessed what I'm going to show you here. I've witnessed many times, and it always seems to point towards globe in my estimation. But again, I'm not saying that means it is a globe. So anyway, we're at 6830, and I'm rambling. Sorry about that. So, this is Granite Peak. It is the same, well, 80 feet lower than our position. And these bottles establish a horizontal line. It's a water level. So, this is what I'm trying to reconcile with flat Earth, because in my mind, I don't know how to do it. It looks to me like I'm seeing what I should see on the globe. Let me move that back a little bit. Right there. So I've got this line created here across these two bottles. It's a horizontal line, and it's way above Granite Peak. I mean, we are talking, when you're up there and looking at it, it looks thousands of feet above Granite Peak. And it looks like that every time I've done the test. And I will also say that you can't see this from here, and you'll have to take my word for it, but I have no reason to lie because I have no agenda other than getting to the truth. That the desert floor, you can't really see it from here, but it seems to come through about where my cursor is here. So that means from here to there is 7,000 feet, because the desert is actually quite low behind the coastal range. There's actually places where it's below sea level. But anyway, so it's 7,000 feet from here to here. And when I was standing up there looking at it, if you were to take that 7,000 foot mountain and cut it in half, and then take that half and apply it to up here, it almost looked like it was exactly equal to that space right there. In other words, the 3,450 feet that should be what we're seeing on a globe is what it looked like to me. It just did. So, for what it's worth. And again, I'm not saying we live on a globe, done deal. This is it. I'm presenting the evidence and my opinion. And I'm willing to be proven wrong, because I don't care if I'm wrong. I just don't care. You can see here that now I've got it a more level. I was adjusting the height of the camera back and forth. So what I want to do is show you something else here. So just to show you how huge this distance is between the horizontal line and the top of Granite Peak. This is Granite Peak. This little mountain here, I don't remember the name, we're going to look at it in a second here, but right here, that is 400 feet lower than Granite Peak. And look at it, it looks like a 1/16 of an inch or an 1/8 of an inch. It's a tiny amount. And I'll show you that right here. So there's Granite Peak, 6749, and here, oh, it's Silver Peak, that's right. It's 6348. So it's 400 feet from there to there. And if you go back to this video, So just keep in mind, there's Silver Peak, there's Granite Peak. They almost look the same height. And again, this was also more noticeable when you're actually standing on the mountain looking at it. It doesn't quite convey in a video. So from here to here is 400 feet. And when you're looking at it, everything looks a little clearer. I mean, it's very easy to see that if you took that little difference and multiplied it times 8 times 4 is 32, that it's going to be really close to that. And again, it's supposed to be 3,400 feet of curvature. And again, I'm simply reporting the data. That's all I'm doing. I'm not, well, I'm giving my opinion, but I'm willing to be wrong and be proven wrong. Absolutely. So how could it be that we're on a flat Earth and that mountain is way down there when it should be up here? I mean, because what I'm then to assume is that I'm looking at some sort of distortion or an illusion. It's something that I'm seeing something that's not actually there. And I know that the argument goes the other way for observations over water, which I've quit doing observations over water because I spent a lot of time researching refraction. And I don't think that they're usable, because you're never going to have a piece of evidence that is irrefutable that the other side will agree with. And maybe you never will anyway. Maybe this won't work either. But I think shooting out into a desert in thin air in the afternoon, there's very little refraction, and I don't know what is going to cause this mountain to sink down that much. And like I said, I've got observations that are 30 miles long, and I'm seeing the same thing. And 30 miles is not a lot of distance to have that sort of distortion, in my opinion, but maybe it is. So why? Why is that mountain that's almost the same height not way up here if the Earth is flat? That's my question. So last thing I want to do is just give you some proof here. This is the same, obviously, clip, but I've got a shot of my compass and then my elevation on the phone, just so that you get some proof that I am where I say I am. But I think it's obvious just by Peak Finder that the view looks the same of the distant mountains. So I'm taking the camera off here, and there we go. So 63 degrees, and let me just show you real quick. Very hard to focus on that. There we go. So it's 63 degrees east, northeast. And if you look, Granite Peak is 61 degrees, so it's very, very close. I think I had my phone just slightly out of alignment. But I wanted to show you that. And then I've also just got a longitude, latitude, which I noticed is actually on the compass as well, you can see there. But I've got latitude, longitude with my elevation somewhere here. Yeah, here we go. So, again, having a hard time focusing in on it, but somewhere here, there it is. So, 6,823 feet, and I'm looking at something that's 6,750, so not a huge difference between these two mountains, especially with that amount of distance between them. Anyway, this is the evidence I'm presenting. I think that surely flat earthers are going to hate me now because they believe that the Earth is flat, and globe earthers are probably going to love me because they believe the Earth is a globe. And I'm just completely neutral in the middle. I don't really care what the shape is. I just would like to know the truth. Hopefully someone who actually just appreciates somebody who's honestly looking for the truth will appreciate my effort here. And I will continue uploading videos. I've got 2 more tests actually already captured, and I'm just going to have to edit them and upload them. And again, they're showing the exact same thing. and I'm seeing it every single time. I've actually got a spot that is 10 minutes from my house that I can look at regularly, and it always shows the same thing, that the mountain that should be level on a flat earth is actually about 600 to 700 feet lower than it should be. Of course, that mountain's only 40 miles away, but again and again and again, I see the same thing. So it's either an illusion, or the earth is a globe, I suppose. I don't really know. But anyway, that's it. Thanks for taking the time to watch my video. I try to make it short, but I always seem to be long-winded. But I do appreciate you stopping by, and please leave a comment, and any rude or illogical comments will be removed. I don't care if you're a globe earth supporter or a flat earth supporter. So if you want to call someone a retard because they believe in flat earth, you're going to have your comments deleted, because I don't appreciate it. Because the flat earth argument is strong and it's convincing, and a lot of people don't have the time to go out and do experiments, and who knows, maybe it actually is flat, and I just don't know. But I am collecting evidence, and it does look to me like potentially it's a globe, but I'm not going to say for sure. Anyway, thanks for stopping by.